In this video, we are going to learn about extremum of functions of two variables. The critical point exists when both first-order partial derivative with respect to x and y are both equals to 0. There are three types of critical points, which are relative minimum point, relative maximum point, and saddle point. The type of critical point can be determined by using second-order partial derivative test. If f sub x is not equals to 0 or f sub y is not equals to 0, there is no relative minimum or maximum points. We can determine the nature of stationary points or critical points by using second-order partial derivative test. To test this, we use the discriminant or d of xy, where it equals to f sub double x multiplied by f sub double y minus f sub xy squared. If the discriminant is greater than 0 and f sub double x is greater than 0, then the stationary point is a minimum point. If the discriminant is greater than 0 and f sub double x is less than 0, then the stationary point is a maximum point. If the discriminant is less than 0, then the stationary point is a saddle point. If the discriminant is equals to 0, then the test failed. It is already explained just now that the stationary point exists when the first-order partial derivative with respect to x and y are both equals to 0. So, the first step is to find the first-order partial derivative with respect to x and with respect to y. Then, the second step is to let both f sub x and f sub y equals to 0. Now, we have two equations in terms of x and y. Solve these two equations by using substitution method. Then, state the stationary point. We use discriminant to determine the nature of the stationary point. So we had to find f sub double x, f sub double y, and f sub xy. F sub double x is the partial derivative of fx with respect to x, so it equals to 6x. F sub double y is the partial derivative of fy with respect to y, so it equals to negative 6y. F sub xy is the partial derivative of fx with respect to y, so it equals to negative 2. Now, substitute all this into the discriminant, where it equals to negative 36xy minus 4. After simplify, use this table where the point is the stationary points. Substitute the point 0, 0 into the discriminant and we get negative 4, which is less than 0. Then we can directly make the conclusion that 0, 0 is a saddle point. Then substitute the point negative 2 over 3 into the discriminant and we get 12, which is greater than 0. If the discriminant is greater than 0, there is possibility that the point either a maximum or minimum point. So we check for the value of f sub double x by substitute negative 2 over 3 and we get negative 4, which is less than 0. Since the discriminant is greater than 0 and f sub double x is less than 0, so the point is a maximum point. In this example, we want to find the stationary points and determine their nature. So the first step is to find the first order partial derivative with respect to x and y, where f sub x is equals to 2xy minus 2y and f sub y equals to x squared minus 2x plus 4y minus 15. Then, let both partial derivative equals to 0. For f sub x, we can directly get the values of x and y. These two values had to be substituted into the other equation, which comes from f sub y equals to 0. Therefore, there are 3 stationary points, which are negative 3, 0, 5, 0, and 1, 4. So now we will determine the nature of the stationary points by using second order partial derivative test. F sub double x is the partial derivative of fx with respect to x. So it equals to 2y. F sub double y is the partial derivative of fy with respect to y. So it equals to 4. And f sub xy is the partial derivative of fx with respect to y. So it equals to 2x minus 2. Then substitute it into the discriminant. Write all the stationary points in the table. Then substitute the point negative 3, 0 into the discriminant, and the value is negative 64. Then we can directly make the conclusion that negative 3, 0 is a saddle point. When substitute the point 5, 0, the discriminant equals to negative 64 as well. So 5, 0 is also a saddle point. And for the point 1, 4, the value of discriminant is 32, which is greater than 0. Then find the value of f sub double x, which is equals to 8 and also greater than 0. So the point 1, 4 is a minimum point.